What we want to be able to do at the end of this video is, regardless of where we place the object, whether we have it beyond C, at C, between C and F, at F, or inside of F, we want to be able to draw the ray diagram and describe the image. Okay? And really, before you even draw the ray diagram, after a little practice, you should be able to describe the image before you even draw the ray diagram, and then you kind of just draw the ray diagram to let your teacher know you know how to draw the ray diagram and to confirm what you know about the image. And you should be able to say something about the location of the image on the principal axis, the size of the image relative to the object, the orientation of the image, and the type of the image. Okay, so here's our first problem. This is the general diagram we're going to use again. Here is the object, here's the principal axis, here's the mirror, and you, your eye, and the object are on the same side as the mirror. If you think about how you use a mirror, usually looking at something, oftentimes it's your face. Okay, so here's the object, and we need to draw the ray diagram. Now before we do that, I just want to remind you, whether it's a concave mirror, a convex lens, a concave lens, or a convex mirror, you should notice that for all four of those things, the ray diagrams are basically drawn the same way. So you don't have to memorize a bunch of different ways to draw the ray diagrams. You just have to memorize the 2 or 3 rules that we're going to use, and then you can apply those rules to all 4 of those optical devices. Okay, so for example, for the concave mirror, the first ray we draw, we're going to draw it from the tip of the object, and it always goes into the mirror parallel to the principal axis. So this light ray comes off the object, it goes into the mirror parallel to the principal axis, and it comes out through F. So it goes like that. So this one has to be parallel, and this ray, when it's reflected off of the mirror, must go through F. It's just not some random angle, this angle in here. It's drawn so that it goes through F. And you should have a nice straight edge and a nice sharp pen or pencil, preferably in case you make a mistake when you draw your ray diagrams. Okay, always use a straight edge. It's not a freehand sketch. All right, the next one goes into the mirror, and it goes into the mirror through F, and then it comes out parallel. So this one's the opposite. The first one we drew was parallel F. This one is F parallel, and you'll notice the lines intersect, the rays intersect right there, and that is where the image appears. Okay, now based on that ray diagram, we can say about the image that when the object is beyond C, greater than C away from the mirror, the image will always be somewhere between C and 2F. The image will always be smaller than the object. When the object is greater than C away, the image will always be inverted, and it will always be a real image. It's an image that is created by converging light rays, and they converge right there at that point. Okay, so before we go on, let's just review this. We drew two rays. Parallel was the first one. F. I like to call the first one parallel F because it goes in parallel, comes out through F. Then the next one, the second one, goes in through F and then comes out parallel. So they're opposites of each other. Now we're going to do the exact same thing. Now we have moved the object so that it is right at C. So we're going to go parallel F, F, parallel, and you'll notice that the object appears the image appears right there. It's at the same place as the object right at C. So when the object is at C, the image must also be at C, or will always be at C. It'll always be the same size. It'll always be inverted, and it's still a real image created by converging light rays. Okay, so those two were basically drawn the same way. The third one, we're going to do the same thing again. Now we have moved the object so it's between C and F. So I pick up my nice sharp pencil and my straight edge. I draw my first ray going in parallel, coming out through F. It must go through this point. The next one goes in through F, comes out parallel. So once again, it must go through this point. You have to draw it through this point. It's not just some random angle or some random ray. It's the one that goes through F, and there is the image. And you'll notice now that the object is between C and F, the image will always be greater than C away from the lens, away from the mirror. The image distance is greater than C. That's what DI stands for, image distance. The image will always be magnified. It's bigger than the object. The image will always be inverted, and it's still a real image. Okay? So you should notice for the first three, we drew them all exactly the same way. Parallel F, F, parallel. And the image appears where those light rays converge, those light rays cross. Okay, now this one's a little different. We're going to draw the first ray exactly the same. Parallel F. Now we can't really draw the F parallel because we're right at F. We have moved the object, so it's right at the focal point. So what we're going to do is we're going to draw a second ray that comes in and strikes the mirror right at the principal axis, like that, and then it's going to reflect at an equal angle. So this angle, the angle of incidence and the angle of reflection, have to be the same. And you'll notice when we're right at F, these light rays do not converge. They're parallel. In order to get an image, as in the previous three examples, the light rays must converge. They must cross. Parallel rays don't cross. Therefore, when you're at the focal point, when the object is at the focal point, when DO equals F, there is no image ever at all, because those light rays are parallel light rays. Okay, so we drew that one a little differently, but it's the same general idea. Okay, here's the last one. Now, finally, we're inside of F. The object is inside the focal point. And you're going to do the same thing with the first one, parallel F. Now, the second one, we're going to draw the same way. We're going to go to the principal axis, and it's going to reflect at the same angle, so that the angle of incidence, this angle, and the angle of reflection, this angle, are exactly the same. And you'll notice these light rays don't converge. They're not parallel, but they actually diverge. Now, your eye is over here. It sees these light rays coming towards it. It notices that the light rays are traveling in a straight line. It doesn't know about any of these reflections off of the mirror, so it assumes they traveled in a straight line, and your brain, your eye, follows those light rays back. It's looking for the intersection of those light rays, and if you follow them back, you draw them nicely with your straight edge and your ruler, you'll notice that those light rays converge right there behind the mirror. Okay, so when you're inside the focal point, you'll notice now our image is behind the mirror, so it's located behind the mirror, and you'll notice that it's switched from being upside down, inverted, to being right side up, which we technically call erect. You'll notice it's magnified, it's bigger, and you'll notice that this is a virtual image. A virtual image is an image that is created by diverging light rays that your eye follows back behind the mirror. If you have a makeup mirror, which a lot of women do for putting on their makeup, you'll notice it's a curved mirror, and you have to get really close to the mirror, and then your eye appears really big. And if you concentrate a little bit, you'll notice that your eye looks like it's coming from behind the mirror. Okay? But it's not. It just appears to come from behind there. That is a virtual image. Okay? So there we go. Those are the 5 cases. You should be able to draw them all now carefully. Straight edge, sharp pencil, make sure all your lines are straight, parallel, and all that stuff. Now, this is a somewhat complicated looking table that summarizes the results of the information we gathered from the video. This is for the concave mirror. This is the object distance. We had greater than C, at C, between C and F, at F, and less than F away. This is the information for the image distance, the image orientation, the size, and the type. Now, on here I have the table for the concave mirrors and the table for the concave lenses. These are both converging devices. Light rays converge when they come into these devices. And you should notice that the answers, the stuff in this gold color, the answers are exactly the same for the convex lens and the concave mirror. For example, when the object is at C, the image is at C, it's inverted, it's the same size, and it's real. For the convex lens, when the object is at 2F, remember F remember 2F and C are the same place on the principal axis, twice the focal length. When the object is at 2F for the convex lens, the image is at 2F. It's inverted, it's equal in size, and it's real. Let's look at one more case. When you're inside of F, the image appears behind the mirror. When you're inside of F, the image appears behind the lens. When you're inside of F, the orientation is erect or upright. When you're inside of F, the orientation is erect. When you're inside of F, the image is magnified, and it's a virtual image. Same thing here, magnified and virtual. The point being, you don't have to memorize the answers for 10 different cases. All you have to do is realize the pattern. As the object gets closer to the lens or the mirror, the image gets farther away and bigger, and it switches from being upside down to right side up when you're inside the focal point.
تجربة المرايا. عندنا نوعين من المرايا عايزين نعين البعد البؤري ليهم. النوع الأولاني اللي هي المرآة المقعرة، دي السطح العاكس بتاعها بيبقى مقعر، ودي بتبقى مجمعة للضوء والبعد البؤري ليها حقيقي. والنوع الثاني من المرايا هي المرآة المحدبة، السطح العاكس بتاعها بيبقى محدب وبيبقى البعد البؤري ليها تخيلي وبتكون مفرقة للضوء. هنبتدي الأول بالمرآة المقعرة. عشان نعين البعد البؤري ليها هنستخدم الجهاز ده. الجهاز ده عبارة عن بطارية باور سبلاي عشان يشغل الضوء ده، وحامل هنا هو عشان أحط عليه المراية، وسكرين عشان استقبل عليها الصورة بتاعة المرايا. طبعا صورة المرايا دايما بتبقى امامها. وعندي هنا اهو في الجهاز مسطرة عشان اقدر اقيس المسافات اللي انا عايزها. هحط المرايا على بعد مناسب من الجسم اللي هو مصدر الضوء اللي عندي، واقيس المسافة من عند الجسم. هنا اهو مثلا هنبتدي لو حركنا الجسم كده شوية هيبقى بادئ من عند 7 سنتي، هتبقى دي بداية المسافة. بعده من المراية هنا هو عند 57. هنطرح ال7 سنتي اللي هي بعد اللي رايح في الأول، يبقى عندي كده بعد المراية عن الجسم 50 سنتي. بعد كده هبتدي أحرك السكرين بتاعتي في الشاشة عشان أقدر أحصل على الصورة قربا وبعدا من المرآة لغاية أما أحصل على أوضح صورة. دي أوضح صورة. لو أنا قربت كده زيادة هلاقي الصورة بتختفي، ولو بعدت عن أوضح صورة هلاقي برضو الصورة بتختفي. فهي في منطقة بتبقى عندها أوضح صورة، هقف عندها وأقيس المسافة من هنا على المسطرة من عند الشاشة لغاية الميرور. هطرح الرقمين من بعض طبعا هيديني بعد الصورة عن المرآة. وبعد كده هكرر نفس الكلام، احرك الميرور لورا شويه كده. وبعد كده طبعا كده بعد الجسم اتغير عن المرايه، وبالتالي بعد الصوره هيتغير. هحرك برضو الحائل لغايه اما استقبل اوضح صوره. هقف كده واقيس بعد الصوره عن طريق بعد الجسم وبعد الصوره. اقدر اعين من القانون العام للمرايا والعدسات البعد البؤري للمرآة المقعره. الجزء الثاني من التجربه عايزه اعين البعد البؤري للمرآة المحدبه. وزي ما احنا قلنا ان المرآة المحدبه دي السطح الخارجي ليها محدب اللي هو العاكس بالمنظر ده، وهي مفرقه للضوء، وفي نفس الوقت البعد البؤري ليها تخيلي. فمش هقدر استقبل صورتها على حائل. عشان استقبل صورتها على حائل لازم استعين بعدسه محدبه. العدسه المحدبه دي مجمعه للضوء. الاول لازم اجيب البعد البؤري للعدسه المحدبه دي لوحدها. فهحط العدسه كده على بعد معين من الجسم، والمسافه من عند الجسم لغايه العدسه هيديني بعد الجسم عن العدسه. وبعد كده بحرك الحائل. طبعا صورة العدسة المحدبة بتبقى خلفها، فهستخدم الحائل ده عشان اجيب بعد الصورة. احرك كده لغاية اما استقبل الصورة. لما تظهر اوضح صورة للعدسة اقيس المسافة من عند الصورة لغاية العدسة، ده هيديني بعد الصورة. ومن خلال القانون العام للمرايا والعدسات اقدر اعين البعد البؤري للعدسة المحدبة دي لوحدها. بعد كده هستخدم السيستم مع بعض اللي هي المراية المحدبة مع العدسة المحدبة. هحط العدسة قدام المراية عشان اقدر استقبل صورة العدسة المحدبة والمراية. فكده الصورة اللي هتنتج عني هتبقى ناتجة من السيستم اللي هي المجموعة الكاملة اللي هي العدسة المحدبة مع المرآة المحدبة الاتنين. هبتدي احرك. احط الاول الجسم على بعد مناسب من المجموعة، وابتدي احرك الحائل بتاعي لغايه اما احصل على اوضح صوره. كده دي اوضح صوره. هقيس المسافه من عند الحائل لغايه المجموعه هيديني بعد الصوره للمجموعه، واقيس المسافه من عند الجسم لغايه المجموعه هيديني بعد الجسم عن المجموعه. وبعد كده هغير المسافة دي، وتبعا ليها هيتغير بعد الصورة. هحرك كده الحائل لغاية اما احصل على اوضح صورة. هقف كده واقيس المسافة من عند الصورة لغاية المجموعة هيديني بعد الصورة، واقيس المسافة من عند المجموعة لغاية الجسم هيديني بعد الجسم. واكرر الخطوة دي كذا مرة. من خلال القانون العام للمرايا والعدسات هقدر احصل على البعد البؤري للمجموعة، ومن خلال معلوميتي للبعد البؤري للعدسة المحدبة لوحدها هقدر اعين البعد البؤري للمرآة المحدبة.